Good evening. 5 envelopes. That is all it took. 5 standard white envelopes, the kind you might use to pay a utility bill or send a birthday card, dropped into a blue postal collection box on a quiet street near Princeton, New Jersey, on the morning of September 18th, 2001. No return address that meant anything, no unusual postage, nothing that would make a postal worker pause, or a mail sorting machine hesitate, or a recipient suspect that what they were holding was anything other than ordinary correspondence. The envelopes passed through automated sorting rollers at processing facilities in New Jersey and Washington, D.C. They rode in mail trucks. They sat in canvas bags with thousands of other pieces of post. And inside each one, pressed into the fold of a typewritten letter, was a powder so fine it was nearly invisible. A powder that, when disturbed, released a cloud of microscopic spores into the air that no one could see, or taste, or feel landing on the wet lining of their lungs. 5 people would die, 17 more would be infected. 32,000 individuals would take emergency antibiotics. The United States Senate would close its doors. And a nation already shattered by the events of 11 days earlier would understand, for the first time in its modern history, that one of the most feared biological agents ever used against it required no laboratory upgrade, no exotic delivery system, and no military program. It required only a stamp. And the organism behind it was already ancient when the first pyramids were built. But here is what very few people understood in the autumn of 2001, and what even fewer understand now. The thing inside those envelopes was not a modern invention. It was not a product of Cold War science or genetic engineering or any particular act of human ingenuity. It was older than the Roman Empire. It was older than the city of Rome itself. It was present in the soil of ancient Egypt when the first pharaohs built the first pyramids. It had been killing livestock and farmers and mill workers and soldiers for longer than written language has existed to record it. What arrived in those envelopes in September 2001 was not a new weapon. It was an ancient one. And understanding the full weight of what that means requires us to travel a very long way back. Before we go further, if these quiet journeys into the darker corners of history give you a place to rest your mind, please take a moment now to hit like and subscribe before you close your eyes. That way, this channel will always be here when you need it. Drop a comment and tell me where in the world you are and what time it is there. I find, more often than I expect, that these stories travel to some very interesting places. Dim the lights a little more. Set your phone face down and let us begin. There is a particular kind of darkness that belongs to the deep past. Not the darkness of ignorance exactly, though ignorance played its part, but the darkness of a world that did not yet have the tools to name what it was encountering. A world in which something could kill thousands of animals and hundreds of people and leave no explanation behind, nothing to examine or understand, nothing to hold up to the light. For most of human history, anthrax existed in precisely that darkness. It did not announce itself with drama. It did not move through populations the way the Great Plagues moved, sweeping through cities in visible waves of suffering and death. It killed more quietly, more selectively, more patiently, emerging from the soil when conditions were right, entering animals through the grass they grazed, spreading to the humans who worked alongside them, and then retreating again back into the earth to wait, always to wait. The oldest evidence of what historians and microbiologists now believe to have been anthrax comes from the earliest written records of human agricultural civilization, from Mesopotamia, from Egypt, from the river valleys where farming and animal husbandry first took hold. Tablets from ancient Assyria, dating to around 1491 BCE, describe a pestilence that moved through livestock with terrible speed, striking the cattle and sheep and camels of those who had, in the words of the scribes who recorded it, displeased the gods. The symptom descriptions are consistent with what we now know as anthrax: sudden death, animals found dead without apparent prior illness, the swelling of tissues, the dark discoloration of the skin and blood. The book of Genesis, in its account of the plagues visited upon Egypt during the time of Moses, describes what scholars have long debated: the fifth plague, a pestilence that struck horses, cattle, donkeys, camels, sheep, and oxen, shares so many characteristics with anthrax that a significant body of biblical scholarship has concluded they are, in all probability, describing the same disease, the sixth plague, which the text describes as producing boils and sores upon the skin of both animals and people, corresponds closely to the cutaneous form of anthrax, in which the spore enters through a break in the skin and produces exactly the kind of dark, coal-black lesion that would eventually give the disease its name. Anthrax, from the Greek word anthracis, coal. The name did not exist yet, of course, in the time of Rameses II, but the disease did. It moved through the sacred herds of Memphis and the grain farming communities of the Nile Delta. The priests who tended the temples, the farmers who worked the fields, the herdsmen who drove the cattle through the green river valleys, none of them had any way of knowing what was killing their animals. It was not the wrath of Osiris or the anger of Ra. It was a bacterium, a microscopic organism that had been present in that same soil for millions of years before any human being had ever set foot on the earth. Ancient Greece and Rome were no strangers to it either. The scholars who study these things believe that Homer, writing in approximately 700 BCE, was describing anthrax in a passage of the Iliad that depicts a sudden and devastating pestilence moving through the army camped before the walls of Troy. Centuries later, Virgil, the Roman poet who lived between 70 and 19 BCE, wrote in his Georgics of a terrible animal disease that swept through the herds of northern Italy, killing cattle and sheep and horses, and leaving behind symptoms that modern readers can identify with reasonable certainty as anthrax. He wrote of the blood that turned black. He wrote of the skin. He wrote of the inexplicable death of animals that had seemed perfectly healthy the day before. Roman agricultural writers documented the disease as a recurring economic catastrophe, one of several afflictions that could devastate a farming estate in a single season. There is even a school of historical thought, marginal but not entirely without merit, that argues anthrax played a contributing role in the broader agricultural collapse that weakened the Roman Empire in its later centuries, as repeated cycles of livestock death depleted the economic foundations of rural communities across Italy and the provinces. Through the Middle Ages, anthrax continued its quiet, persistent presence. European accounts from the 10th, 11th, and 12th centuries describe episodes of sudden mass livestock death in England, France, Germany, and the Low Countries that matched the pattern of anthrax outbreaks. It was known by many names across different regions and languages: the black bane, the charbon, the splenic fever, the Cumberland disease, the Siberian plague. Each name reflected a different understanding, or more precisely a different misunderstanding of what caused it. None of the names reflected the truth, because the truth, the actual biological mechanism, was beyond the reach of anyone who tried to grasp it. And this is the thing about anthrax that takes a moment to fully absorb, even now with the benefit of everything modern science has revealed. The reason anthrax was so persistent, so recurring, so impossible to eradicate from any piece of land where it had once appeared, was not because the bacteria lingered in the bodies of dead animals. The bacteria themselves, the living, active, vegetative form of Bacillus anthracis, are actually relatively fragile. They die with the animal that hosts them. They do not last long in the open air or in hostile environments. They are, in the vegetative state, just bacteria, vulnerable to the same forces that destroy other bacteria. But anthrax does not survive as bacteria. It survives as something else entirely. When the conditions in its environment become unfavorable, when nutrients run out, when the host animal dies, when the temperature drops or the moisture disappears, Bacillus anthracis performs what can only be described as a remarkable biological transformation. It retreats inside itself. It condenses its genetic material into a dense, tightly packed core. It surrounds that core with layer after layer of protective coating, a shell so tough, so chemically resistant, so extraordinarily engineered by millions of years of evolution, that it becomes effectively immune to almost everything the natural world can throw at it. It becomes a spore. And a spore is not alive in the way we normally understand living things to be alive. It does not breathe. It does not eat. It does not reproduce. It does not age. It simply exists, suspended, inert, waiting, in a state that is neither quite life nor quite death, but something in between. Something patient in a way that nothing else in nature is patient. A spore can survive boiling water. It can survive freezing temperatures of -40 degrees. It can survive decades, in some documented cases more than a century, in dry soil, maintaining its complete viability, ready to germinate the moment a warm, moist, nutrient-rich environment presents itself. It is resistant to most standard disinfectants. It can survive ultraviolet radiation that would destroy most other organisms. It has been recovered from archaeological sites, from ancient battlefields, from soil that had not been disturbed in generations, and found still fully capable of causing disease. Think, for a moment, about what this means for a piece of farmland. An animal dies of anthrax in a field, perhaps a cow or a sheep or a horse. Before it dies, in the final hours of the infection, it sheds spores into the surrounding soil through its blood and bodily fluids. Millions of spores, hundreds of millions of spores. They enter the ground. The animal is buried or consumed by scavengers or burns. But the spores remain. Decades pass. Other animals graze that same field, and the spores are undisturbed and nothing happens. A drought comes and the soil contracts. Then rain and the soil expands. A flood passes through and churns up the earth. And suddenly the spores are at the surface again, exactly where grazing animals will encounter them, exactly where the cycle will begin again. Ancient farmers who lost their herds to anthrax and avoided those fields for a generation or 2 generations sometimes returned to find that the disease had not gone away. It had simply been waiting. That patience, the patience of an organism that has no concept of time, that neither ages nor decays, that simply exists until the conditions for its revival return, is unlike anything else in the biological world. It is not survival. It is suspension, and it can last as long as the earth itself endures. This is what the priests of Memphis did not understand. This is what the Roman agricultural writers could not explain. This is what the Assyrian scribes attributed to divine punishment. Because what else could it possibly be? What else could kill a herd of cattle and then lie quiet for 40 years and then kill again? To the people who lived with anthrax through the ancient and medieval worlds, its behavior was deeply, fundamentally inexplicable. There was no invisible organism theory. There was no germ theory. There was no concept of the spore. There was only the terrible experience of watching animals die, and the soil that seemed to carry memory, and the profound and unanswerable mystery of why. The disease that killed animals in the fields of Egypt, and the pastures of Mesopotamia, and the farms of Roman Italy, was not understood. It was feared. It was named. It was written about in tablets and papyri and manuscripts and agricultural handbooks across 30 centuries of recorded history. But it was not understood, not until the second half of the 19th century, not until a young German country doctor, working alone in a cramped and poorly lit laboratory in a small provincial town in what is now Western Poland, looked through his microscope at a droplet of blood taken from the body of a dead cow, and saw something that had never been described before. Something rod-shaped. Something that did not belong in the blood of a healthy animal. Something that, if he was right about what he was seeing, would change the entire history of medicine. His name was Robert Koch. He was 32 years old. He had no laboratory assistant, no institutional backing, no funding beyond what his modest income as a district physician allowed him. His microscope was a gift from his wife. His laboratory was a converted corner of his patient examination room in the town of Woolstein. And in that room, looking at the black blood of animals that had died of anthrax in the surrounding countryside, he was about to do something that no human being had ever done before. He was about to prove with scientific rigor that a specific, identifiable, living organism caused a specific disease. Not miasma, not divine anger, not bad air or humoral imbalance, or the mysterious emanations that had been invoked to explain illness for 2,000 years of medical history. A bacterium, a visible, isolatable, cultivable, reproducible bacterium. And more than that, much more than that, he was about to discover what the bacterium did when conditions became hostile. He was about to find the spore, and in finding the spore, he would finally give humanity the first real explanation for something ancient farmers had experienced and feared and failed to understand for 3,000 years: the terrible, patient memory of the soil. What Koch discovered was not simply that the spore existed, but what it did after it was inhaled. When the spore of Bacillus anthracis enters a warm-blooded body, enters the wet, oxygen-rich, nutrient-dense environment of the lungs, it does not remain a spore. Something in that environment signals to it that the long wait is over. It germinates. The protective shell dissolves. The dormant genetic material stirs. Within hours, the spore has transformed back into the active vegetative form of the bacterium, and it begins to do what bacteria do: divide, multiply, spread. It moves from the lungs into the lymphatic system, and from there into the bloodstream. As it travels, it releases toxins. three separate proteins that act in combination with a ferocity that has few parallels in the microbial world. One toxin disables the immune cells that would normally swarm a bacterial infection. Another causes the catastrophic fluid accumulation in tissues that produces the characteristic swelling of inhalation anthrax. The third, called lethal toxin, attacks the signaling pathways that cells use to coordinate their response to invasion, silencing them one by one until the body's ability to mount any coherent defense simply collapses. By the time visible symptoms appear, the fever, the fatigue, the apparently flu-like onset that deceives both patients and doctors, the bacteria are already present in the blood in quantities that antibiotics, even when administered correctly, can struggle to overcome. It is the toxins, more than the bacteria themselves, that kill. And unlike the bacteria, the toxins persist in the bloodstream even after the bacterial population has been destroyed, continuing their work. But the fields of Bradford, England, in the 1840s were about to tell their own dark story first, one that would help point Koch toward the discovery that was waiting for him. And that story, and what it cost the workers who lived it, is where we go next. Bradford, England, in the middle years of the 19th century, was a city in the grip of its own transformation. It was a city of wool, or more precisely, a city of wool's ambitions. The Industrial Revolution had pulled the old cottage trade of the West Riding of Yorkshire into the factory age, and Bradford had become the undisputed centre of the global wool textile industry. By the 1840s, more than 900 mills operated within the city and its surrounding districts. Streets that had been farmland a generation earlier were now dense with mills and terraced housing, and the peculiar grey haze of industrial smoke that settled over the valley in all seasons. 25,000 wool sorters and textile workers and their families lived and worked in the city's long shadow. The work of a wool sorter was not glamorous work, and it was not safe work, but it was skilled work, and for those who performed it, it was work that carried a certain pride. A wool sorter's task was to open the compressed bales of raw wool that arrived by ship from South America and Central Asia, from Peru and Argentina, from Asia Minor and the plains of the Middle East, and sort the fibers by quality, length, and texture before they entered the production process. The wool came compressed tightly, damp from the voyage, fragrant with lanolin, and the accumulated smells of wherever it had come from. And sometimes, in some of those bales, there was something else. No one understood in the 1840s what it was. No one had the conceptual framework to understand it. But from the late 1840s onward, a pattern began to emerge among the workers of Bradford's wool industry that was deeply, persistently troubling. Workers who spent their days opening and sorting the imported alpaca and mohair bales began to fall ill. Not all of them, not in any predictable sequence, but enough and with enough consistency that the connection to the work itself became impossible to ignore. The illness was not subtle. It did not announce itself with a mild fever and a day in bed. It arrived with a suddenness that was startling even to the physicians who were called to the bedsides of its victims. A worker might sort wool in the morning, feel a headache by afternoon, and by the following day be dead. The speed was part of what made it so frightening. Fever would come, then difficulty breathing, then a rapid collapse of the lungs, then a kind of internal darkness that the attending physicians struggled to describe in their case notes. Many never had time to call a doctor at all. Some dropped dead at their sorting tables, with no warning beyond a brief complaint of feeling unwell. Those who developed the cutaneous form, which occurred when the spores entered through a small cut or abrasion on the skin, fared slightly better, though not by much. A dark, painless pustule would form at the point of entry. The skin around it would blacken and die. The lesion would expand. Without treatment, the infection could spread to the bloodstream and kill within days. Bradford's medical community was confronted with a mystery it could not solve. The disease killed quickly. It appeared to strike at random within the workforce. It seemed to come from the wool or from something in the wool. But what exactly that something was remained entirely beyond the reach of medicine as it was then practiced. Local physicians began calling it the Woolsorter's disease. The French, with a darker wit, began calling it La Maladie de Bradford, the Bradford disease, as if the city itself had generated the affliction. It was killing workers regularly through the 1850s, the 1860s, the 1870s. The mill owners were aware of it. The local medical community was aware of it. The workers themselves were deeply, practically aware of it. They knew that opening certain bales was more dangerous than opening others, that certain origins were more suspect than others, though they could not have said why with any scientific precision. They knew in the accumulated practical wisdom of people who work in dangerous places that the disease came from somewhere inside the wool, and that it could reach up out of a bale and kill you before you had any chance to understand what had happened. It was not until 1878 that a Bradford physician named John Henry Bell published his findings linking the Woolsorter's disease directly to anthrax, demonstrating through careful clinical observation that the mysterious industrial killer of the Bradford mills and the ancient agricultural plague that had been killing livestock for 3,000 years were one and the same organism. Bell found Bacillus anthracis in the blood of victims who had died of the Woolsorter's disease. The connection was made. The mystery, at least partly, was resolved. But understanding what the organism was, really understanding it at the level of its biology and its extraordinary survival mechanism, had already begun 2 years earlier in a very different setting. Not in the industrial West Riding of Yorkshire, but in a small, quiet, rural town in what was then the German province of Posen, in the man who would become the most important figure in the entire history of infectious disease. Robert Koch was 32 years old in 1875 when he began his serious investigation of anthrax. He was working as a district physician in Wolstein, a provincial posting that was respectable enough, but far from the centers of scientific activity in Berlin and Vienna and Paris, where the major debates of medicine were being conducted. He had no access to a proper laboratory. He had a microscope, a Zeiss instrument that his wife had given him as a birthday gift, and a small workspace carved out of the corner of his examination room, where he examined patients by day and peered at microorganisms by night. The countryside around Wolstein had anthrax. It was a recurring affliction of the local livestock, the kind of thing that local farmers accepted as an occupational fact, a periodic devastation that might take half a herd and leave nothing behind except grief and the unavoidable question of why. Koch watched it. He took samples. He looked at the blood of dead animals under his microscope, and what he saw, those fine rod-shaped structures, those dark and distinctive forms that were simply not present in the blood of healthy animals, convinced him that he was looking at the cause of the disease, not a symptom of it, not a byproduct of it, the cause itself. This was, in 1875 and 1876, a contested proposition. The germ theory of disease, the idea first articulated systematically by Louis Pasteur, that specific microorganisms caused specific diseases, was gaining ground but had not yet fully displaced the older framework. There were serious scientists who still believed that disease arose from the corruption of the air, or from miasmas, or from some broader environmental imbalance. To demonstrate conclusively that a specific bacterium caused a specific disease required more than observation. It required proof, a chain of evidence so clean and so rigorous that it could not be disputed. Koch spent the better part of a year constructing that chain. He isolated the bacteria from the blood of dead animals. He cultivated them in pure cultures, growing them outside any living body, in drops of nutrient solution suspended beneath glass slides, using a technique he invented himself that he called the hanging drop method. He watched the bacteria under his microscope as they multiplied and grew. And then he did something that no scientist had done before with this organism. He noticed that under certain conditions, the rod-shaped bacteria changed. They produced spores. Not right away, not always. But when the nutrient solution was depleted, when the environment became hostile, the bacterial cells began to generate small, dense, shining bodies, visible under the microscope as bright oval shapes within the bacterial rods, and then, eventually, as independent structures after the bacterial cell wall had dissolved away. Koch observed these spores for days. He watched them remain inert through conditions that would have killed any living cell. And then he watched them germinate, spring back into active, multiplying bacteria, when he transferred them into a fresh, warm, nutrient-rich environment. Here was the answer. Here was the explanation for everything that had baffled farmers and physicians and natural historians for 3,000 years. The soil did not simply become contaminated with anthrax and stay contaminated in some vague, indefinite way. It became contaminated with anthrax spores, microscopic, armored, virtually indestructible spores that could outlast almost any environmental condition and then return to lethal life when a warm-blooded animal disturbed the earth and breathed them in, or consumed grass that carried them. Koch published his findings in 1876 in a paper titled The Etiology of Anthrax Disease. He published the first photographic images of bacteria in 1877. He demonstrated what he called the postulates, the 4 criteria that must be met to prove that a specific organism causes a specific disease. And in doing so, he did not merely solve the mystery of anthrax. He laid the conceptual foundation for all of modern microbiology. Every subsequent identification of a bacterial pathogen, every proof of disease causation, every vaccine and antibiotic that followed in the next century and a half rested on the logical structure that Robert Koch built in that cramped examination room in Wolstein, using a microscope his wife had bought him. He was not a celebrated figure yet. He was a country doctor who had made a discovery of enormous importance in a laboratory that would not have impressed anyone. But word traveled. His paper came to the attention of Ferdinand Kohn, a professor of plant physiology at the University of Breslau, who understood immediately what he was looking at. Kohn invited Koch to demonstrate his findings in person, and Koch traveled to Breslau and showed the assembled scientists his cultures, his photographs, his spores. The response was not immediate public acclaim. Science rarely works that way. But among those who understood what Koch had demonstrated, the reaction was something close to awe. He had proven that the ancient and terrible mystery of the soil, remembering anthrax, was not a mystery at all. It was a biological mechanism, elegant in its simplicity, devastating in its implications, and now, for the first time, fully understood. 5 years later, in 1881, a rather different kind of scientist took up the anthrax story and turned it into spectacle. Louis Pasteur was 58 years old and one of the most famous scientists in France when he announced in February of that year that he had developed a vaccine capable of protecting animals against anthrax. The Agricultural Society of Melun issued him a public challenge: prove it. Pasteur, who was never averse to drama, accepted immediately, despite the private reservations of his own colleagues and his own inner uncertainty about whether the vaccine was truly ready. The demonstration took place at a farm in the village of Pouilly-le-Fort, 40 kilometers south of Paris. It began on May 5th, 1881. 2 groups of animals were assembled. 24 sheep, 1 goat, and 6 cows received 2 rounds of Pasteur's attenuated anthrax vaccine, a weakened form of the bacterium rendered less virulent by exposure to oxygen, administered on May 5th and again on May 17th. A control group of equal size received no vaccine and no protection. On May 31st, all the animals, vaccinated and unvaccinated alike, were injected with a full-strength, lethal dose of live anthrax. The observers were asked to return on June 2nd. When they arrived at the farm on that June morning, the farmers and veterinarians and journalists and agricultural officials who had come to see the results, what they found was unambiguous. All 24 vaccinated sheep were alive and healthy. All 24 unvaccinated sheep were dead. Several of them had collapsed in the field and died while the spectators watched. The unvaccinated goat was dead. The 4 unvaccinated cows were sick, though they would survive. It was, as one historian has described it, the most dramatic scientific demonstration of the 19th century. The vaccine worked. The germ theory of disease was not merely confirmed. It was vindicated in front of an audience, in a field, in full view of people who had every reason to be skeptical and who left that field as believers. Between 1882 and 1893, nearly 4 million animals in France alone were vaccinated against anthrax, and the losses from the disease fell sharply. Koch had named the enemy and revealed its mechanism. Pasteur had shown that the enemy could be defeated. For a brief, optimistic moment, it seemed possible to imagine that anthrax might follow the trajectory of other agricultural diseases, that science and public health and the diligent application of what had been learned might eventually reduce it to a historical footnote, a problem that had once been terrible and was now managed. But that optimism rested on an assumption that turned out to be incorrect. It assumed that the only people paying attention to what Koch and Pasteur had discovered were doctors and farmers and public health officials. They were not. Somewhere in the governments and military establishments of Europe, other people were paying attention too, people who read the same papers and heard the same reports and looked at the same extraordinary biology. The immortal spore, the invisible aerosol, the near-perfect lethality in the lungs, and drew a very different conclusion from what they learned. If you could weaponize this, they understood, you would not need an army. You would just need the wind. And that realization, quiet, strategic, cold, marks the point where the story of anthrax turns a corner from which it never quite returns. There is a particular kind of horror that belongs not to accidents or to nature, but to intention, to the moment when a human mind looks at something destructive, something ancient and indifferent and terrible, and decides with deliberate calculation to make it worse, to contain it and concentrate it and point it at other human beings. That moment arrived for anthrax in the early years of the 20th century. It did not arrive all at once. There was no single meeting, no single decision, no one morning on which a government woke up and chose to weaponize a 3,000-year-old plague. It happened gradually, as these things tend to, through the accumulated logic of military necessity and strategic competition and the terrible arithmetic of modern warfare, which had begun to demand casualties on a scale that conventional weapons alone could not reliably deliver. The German military program of World War I was the first state-sponsored effort to weaponize anthrax deliberately and deploy it against an enemy. The program was not aimed at soldiers on a battlefield. It was aimed at something more economically devastating, at the animals and the food supply that kept the Allied nations functional. German agents operating in neutral countries, including Romania, the United States, and Argentina, attempted to infect mules and horses and cattle destined for Allied forces with anthrax and a related organism called glanders. The animals were infected through feed laced with bacterial cultures. The effort was, by the standards of later biological weapons programs, crude and only partially effective. But it established something important. It established that anthrax could be used as a weapon of state, that the biology which killed Bradford's Woolsorters and Egypt's sacred herds could be deliberately directed by a government toward a military objective. The idea did not die with the armistice of 1918. It was absorbed, refined, and accelerated. Through the 1920s and 1930s, the major military powers of the world watched each other with increasing unease across the question of biological weapons. The Japanese military program, centered at a facility in Manchuria, known as Unit 731, was the most extensive and the most brutal, conducting lethal experiments on human subjects and developing anthrax and plague and cholera as weapons to be deployed against Chinese civilian populations. The Soviets were building their own program, quietly, in facilities that the outside world could not inspect. The British were watching and thinking, and eventually concluding that they could not afford to be the only major power without a capability in this domain. And then came September 1939, and the calculus changed entirely. War with Germany meant war with a power that the British military establishment believed might already possess or be developing biological weapons of its own. The question was no longer whether Britain should pursue a biological weapons program. The question was how quickly it could be built and how effective it could be made. The United States had reached a similar conclusion somewhat earlier. Beginning in 1942, the American biological weapons program was headquartered at a facility called Camp Detrick, later renamed Fort Detrick, in Frederick, Maryland. By the early 1950s, the facility employed several thousand scientists and support staff working across dozens of buildings, developing a range of biological agents that included anthrax, brucellosis, botulinum toxin, and others. The American program was never deployed in combat, and unlike the Soviet program that would later dwarf it in scale, It operated within the framework of periodic government reviews and eventually a formal political decision about its future. That decision came on November the 25th, 1969, when President Richard Nixon signed an executive order renouncing all offensive biological weapons, unilaterally, without waiting for a reciprocal Soviet gesture. The United States destroyed its entire biological weapons stockpile. In 1972, the International Biological Weapons Convention was opened for signature, prohibiting the development, production, and stockpiling of biological weapons. The Soviet Union was among the signatories. As subsequent history would reveal, the Soviet Union's signature was not worth the paper it was printed on. While the ink was still drying on the Biological Weapons Convention, Soviet scientists were expanding their program, not shutting it down. The treaty did not end their weapons effort. It gave it better cover. But before that revelation, the story of Anthrax's weaponization had its most vivid and most lasting chapter on a small island off the northwest coast of Scotland. Gruinard Island was not a significant place. It was 196 hectares of windswept moorland and rough grass, approximately 2 kilometers long and 1 kilometer wide, separated from the Scottish mainland by less than a kilometer of cold Atlantic water. It had been inhabited once. The census of 1881 recorded 6 residents, but by the early 20th century it had been long abandoned, its small population having drifted away to the mainland, leaving behind only the stone foundations of cottages and the patterns of old field walls. It was remote. It was uninhabited. It was close enough to the mainland for scientists to travel there and return in a day, and it was owned privately, which meant it could be quietly requisitioned by the British government without public announcement or parliamentary debate. In 1942, the War Office purchased Gruinard Island for £500. It was given the designation X-Base, and scientists from Port on Down, the British government's biological and chemical research facility in Wiltshire, arrived on the island with a purpose that would not be made public for decades. The anthrax strain they brought with them had been supplied by Roy Lars Vollum, a professor of bacteriology at the University of Oxford. It was designated Vollum 14578, and it was chosen because it was exceptionally virulent, among the most lethal strains of Bacillus anthracis known to science at the time. The experiment was straightforward. 80 sheep were transported to the island and tethered in groups at measured distances from a central point. A bomb filled with anthrax spores was mounted on a pole and detonated. The resulting cloud, visible on the film footage that Porton Down scientists made of the tests, a brownish aerosol drifting on the Atlantic wind toward the tethered animals, spread outward across the island. Then they waited. The sheep began to fall ill within 48 hours. They began to die within 3 days. Every one of them. Some of the experiments were recorded on 16mm color film, which remained classified until 1997. The footage shows the detonation of the bomb, the drifting cloud, and then, in subsequent frames, the dead sheep. It is quiet footage. There is no sound. The island is green and the sky is grey, and the animals are dead, and there is a kind of matter-of-fact horror to the whole record that is more disturbing, in some ways, than any dramatization could be. The scientists drew their conclusions methodically. A large-scale release of anthrax spores over a populated area, they determined, would be catastrophically effective. The spores would infect anyone who breathed them within the contaminated zone. The mortality rate for inhalation anthrax, untreated, approaches 100%. And this was the part of the conclusion that carried the most weight. The spores would not dissipate after the attack. They would settle into the soil. They would persist, exactly as Koch had discovered in Wolstein in 1876 for decades. German cities targeted with anthrax bombs would not merely suffer casualties in the immediate aftermath. They would remain uninhabitable for a generation, perhaps longer. This was the conclusion that Winston Churchill found so compelling. He is reported to have been deeply enthusiastic about the potential of anthrax as a strategic weapon. "I don't see why the devil should have all the best weapons," he reportedly said of the biological program. A plan was drawn up, Operation Vegetarian, which called for the production of 5 million small linseed cake pellets, each laced with anthrax spores, to be dropped by aircraft over the pastures and farmland of Germany. Cattle would eat the pellets, the cattle would die, the German food supply would be devastated. The human population who consumed contaminated meat or simply inhabited contaminated land would begin to die too, and the land itself would be poisoned for decades. The linseed cakes were actually made, 5 million of them, produced at a facility in Sutton, Bonington, Nottinghamshire. They sat in storage, ready. The order to deploy them was never given. The war ended before the decision was forced. And in 1945, the cakes were incinerated, their destruction carefully documented. But Gruinard Island remained. The problem, which the scientists had understood even as they conducted the tests, was that there was no known method of decontaminating a landscape that had been seeded with anthrax spores. The island had been sacrificed knowingly. It had been designated, in the terminology of the program, a sacrifice zone. And when the owner sought its return after the war ended in 1945, the Ministry of Supply acknowledged the obvious. The island was contaminated, and there was nothing they could do about it. The government acquired the island outright. A deal was struck. The owner's heirs could repurchase it for £500 when it was declared fit for habitation by man and beast. Warning signs were erected around the island's shoreline. Periodic checks by Porton Down personnel confirmed year after year that the spores remained viable. The island sat off the Scottish coast, green and windswept and completely uninhabitable. Through the 1950s and the 1960s and the 1970s, a small and largely forgotten monument to the logic of biological warfare. It might have remained forgotten except for the autumn of 1981. In September of that year, British newspapers began receiving letters signed by a group calling itself the Dark Harvest Commandos. The letters were not threats in the conventional sense. They were demands. The group claimed to have landed on Gruinard Island and removed 300 pounds of contaminated soil, and they stated their intention to deposit samples of that soil at locations across Britain until the government committed to decontaminating the island. The government's initial response was dismissal. Contaminated soil from Gruinard Island had never, in nearly 40 years, left the island. The claims seemed implausible. Then a sealed package arrived outside the gates of Porton Down. Tests were conducted. The package contained anthrax bacilli. The soil was from Gruinard. Days later, another package was left at the venue where the Conservative Party was holding its annual conference in Blackpool. This sample tested negative. The soil was similar in composition to Gruinard, but did not contain live anthrax. But the message required no interpretation. The Dark Harvest Commandos had the real thing. They had demonstrated they were willing to use it as a threat, and they could apparently deposit it wherever they chose. The identities of the group's members were never established. Police investigations led nowhere. The group itself dissolved without further action, having made its point, and the point quietly was registered. It would take 5 more years for the decision to be made and the funding to be allocated. In 1986, a determined effort to decontaminate Gruinard Island finally began. 280 tons of formaldehyde solution diluted in seawater were sprayed across all 196 hectares of the island. The most heavily contaminated soil around the original detonation sites was physically removed. Sheep were reintroduced to the island as a test and monitored closely. They remained healthy. On April 24, 1990, 48 years after the first anthrax bomb was detonated on Gruinard, a junior defense minister named Michael Neubert visited the island and removed the last of the warning signs that had ringed its beaches since the war. The island was declared safe. The original owner's heirs repurchased it for £500. The quarantine was over. The anthrax was gone. Or more accurately, and the distinction matters because it always matters with anthrax, the anthrax had been reduced to a level that was no longer considered dangerous to animals that grazed there. Whether the last spore on Gruinard Island was truly destroyed in 1986 is a question that no one can answer with complete certainty, and that no one particularly wants to test. But even as the British program was being wound down, and the island was being decontaminated, and the warning signs were finally coming off those Scottish beaches, something else was happening on the other side of the world. Something far larger. Something built not on the scale of a small island off the Scottish coast, but on the scale of an industrial operation, employing tens of thousands of people, producing anthrax by the ton, and loading it into the warheads of intercontinental ballistic missiles aimed at the cities of the West. The Soviet Union had been building its biological weapons program since at least the late 1920s, and by the late 1970s, it had become the largest and most sophisticated biological weapons effort in human history. The program had a name, Biopreparate, and it employed, at the height of its operations in the 1980s, approximately 60,000 scientists, engineers, technicians, and support personnel working at dozens of facilities across the Soviet Union, many of them hidden inside what appeared to be ordinary public health research institutes. And in the spring of 1979, in a closed Soviet city called Sverdlovsk, something in that program went terribly, irreversibly wrong. The city of Sverdlovsk, in the spring of 1979, was a city that did not officially exist in the way most cities exist. It was real, of course. A large industrial city of more than 1 million people, situated roughly 1,400 kilometers east of Moscow, near the eastern slope of the Ural Mountains, at the geographic boundary between European and Asian Russia. It had factories and apartment blocks, and schools and hospitals, and tram lines, and all the ordinary infrastructure of a Soviet city of its size. But it was closed. Its boundaries were restricted to foreigners, its internal affairs were classified, and its true function within the Soviet military-industrial complex was something that the outside world could only infer from the narrow and carefully managed information that the Soviet state chose to release about it. Foreigners had never been permitted inside its gates. Western intelligence services had spent decades assembling fragments of information about it from defectors and satellite imagery and signals intelligence. And what they assembled was a picture of a city that was, in its true character, more military installation than civilian community. By the 1970s, 87% of Sverdlovsk's industrial production was military. It produced tanks and ballistic missiles and rockets and armaments of every description. It was one of the nerve centers of the Soviet defense apparatus, and among its many hidden facilities was one that appeared, on official documentation, to be an ordinary public health research institute. It was not. The facility was known internally as Military Compound 19, or simply Compound 19. It occupied a site on the southern edge of the city, built on land that had formerly housed a military academy, and it had been operational since 1949, constructed using technical knowledge extracted, in part, from Japanese scientists captured at the end of World War II, scientists who had participated in Unit 731's biological warfare program in Manchuria. From its earliest years, Compound 19 had been a production facility. Not a research facility, not primarily, but a production facility, manufacturing dried biological agents in powdered form at industrial scale for incorporation into the Soviet Union's strategic weapons arsenal. The strain of anthrax produced at Compound 19 was known internally as Anthrax 836. It had been selected not because it had been engineered or modified. It had not been, as subsequent investigation would reveal, but because it was, of all the naturally occurring strains of Bacillus anthracis that Soviet scientists had evaluated over decades of research, the most devastatingly lethal to human beings. It had been isolated following a separate anthrax accident in the Soviet city of Kirov in 1953, when a leak from a bacteriological facility had contaminated the city's sewer system, and a biologist named Vladimir Sizov had subsequently recovered an exceptionally virulent strain from rodents captured in the affected area. That strain became the foundation of Sverdlovsk's production. It was, by the late 1970s, being produced in quantities sufficient for loading into the warheads of SS-18 intercontinental ballistic missiles. The missiles that, in the event of war with the West, would arc over the North Pole and descend on American cities. 3 shifts operated at Compound 19, around the clock, 7 days a week. The production process required drying the anthrax spores, converting them from a wet culture into a fine powdered aerosol, capable of being dispersed from a missile warhead. The drying equipment generated a continuous flow of exhaust air, carrying anthrax particles. This exhaust was passed through a series of large filters before being vented to the outside atmosphere. The filters were the only thing standing between Compound 19's production output and the city of Sverdlovsk, the surrounding residential neighborhoods, the schools and apartment blocks, and streets where the people who lived and worked in that closed city went about their lives, entirely unaware of what was being manufactured a kilometer or two from their windows. On the last Friday of March 1979, most sources place the critical event as April 2nd, though some accounts suggest it began on March 30th. A technician in the production unit removed a clogged filter from the exhaust system during routine maintenance. The filter needed to be replaced. He left a note in the maintenance log documenting that the filter had been removed and required replacement before operations resumed. The note was written clearly. The instruction was unambiguous. The note was not acted upon. The next shift supervisor either did not see the note or did not understand its significance, or made the assessment that production could resume without first addressing the maintenance issue. The drying equipment was restarted. The exhaust system resumed operation. And for some period of time, hours perhaps, the exact duration was never established with certainty. The exhaust from the anthrax production facility vented directly into the outside air without passing through any filtration at all. The wind that night was blowing southeast. What followed was not dramatic in the way that disasters are sometimes dramatic. There was no explosion, no visible cloud, no alarm, no immediate sign that anything had gone wrong. The spores were invisible. They dispersed on the spring air over the residential neighborhoods that lay downwind of Compound 19, the Chkalovsky district, and the factory workers' apartment blocks, and the streets where people walked home from work in the last light of the day, and children played outside in the April evening, and the ordinary, unhurried life of a Soviet city continued without interruption or awareness. No one who breathed those spores in that first hour felt anything. That is one of the most unsettling properties of inhalation anthrax, and it is worth dwelling on for a moment. The initial exposure produces no symptoms whatsoever. The spores settle in the deep tissue of the lungs, in the tiny air sacs at the ends of the bronchial tree, where the lungs and the bloodstream meet. And the body does not immediately respond. There is no coughing, no shortness of breath, no sensation that anything has entered the respiratory system. The person who has just been infected has no way of knowing what has happened. They go home, they have dinner, they watch television or read or talk to their families or simply sleep. For anything between 1 and 5 days, sometimes longer, they feel entirely well. The spores are germinating quietly in their lungs. The bacteria are multiplying, and the toxins are beginning to accumulate. But none of this is yet visible from the outside or detectable from the inside. In the days that followed the release, something began to spread through the downwind neighborhoods of Sverdlovsk that Soviet doctors had almost never encountered. It began like influenza, fever, muscle aches, fatigue, a cough, the kinds of symptoms that prompt a person to take a day away from work and rest, to drink tea and expect to feel better by tomorrow. But unlike influenza, it did not plateau. It progressed with a speed that attending physicians found increasingly alarming, through an initial phase of apparent improvement, a brief window, sometimes a matter of hours, in which patients seemed to stabilize, and then into a catastrophic collapse, massive internal bleeding, fluid filling the lungs, extreme swelling of the mediastinum, the central cavity of the chest, which gives pathological specimens from inhalation anthrax a characteristic appearance on autopsy that is unlike almost any other cause of death. Death in most cases within 24 to 36 hours of the onset of the severe symptoms. Some patients died faster. The first deaths were reported in early April, then more. The pattern was unusual in ways that troubled the Soviet physicians, seeing the cases accumulate, not in the great teaching hospitals of Moscow, but in the district hospitals and polyclinics of Sverdlovsk's southern neighborhoods, where exhausted doctors were trying to understand what was killing their patients faster than they could arrive at a diagnosis. The Soviet authorities responded quickly and in 2 distinct directions simultaneously. The first direction was medical. A Moscow-controlled emergency commission was established. On April 22nd, 3 weeks after the initial release, workers began hosing down buildings throughout the affected district with chlorine solution. Trees along the streets were cut down and removed. Stray dogs and cats were killed. The roads were washed repeatedly. The medical facilities in the affected area received supplies of the Soviet anthrax vaccine. And by the end of the emergency program, approximately 80% of the eligible population in the Chkalovsky district, roughly 47,000 people, had been vaccinated, though the vaccinations came far too late for those already infected and far too late for those already dead. The second direction was deception. The cover story was simple and in its way almost elegant in its reliance on the genuine properties of anthrax. Anthrax did naturally occur in livestock. People did occasionally contract it from contaminated meat. The deaths, Soviet authorities announced, had been caused by gastrointestinal anthrax, the form of the disease contracted by eating tainted meat from animals infected with naturally occurring anthrax in the area. There had been an illegal black market slaughter of infected animals. The meat had been sold and consumed. The deaths were a public health tragedy, but a natural one, entirely unrelated to any military facility. Medical records were removed from hospitals and replaced with falsified documents. Death certificates were altered to record causes of death consistent with the contaminated meat account. The pathologists who had performed autopsies on the victims, and who had, in some cases, had the presence of mind and the professional integrity to preserve tissue samples that would later prove invaluable to investigators, were pressured to conform their official findings to the story Moscow had authorized. The families of the dead were told what they were told and expected to accept it. The cover story had structural problems from the beginning, and Western analysts who studied it noticed them. The victims, almost without exception, were adult men of working age, predominantly those who had been outdoors in the downwind zone on and around April 2nd. This was not the demographic profile of a community that had eaten contaminated black market meat, which would have spread illness more randomly across ages, genders, and households. It was the demographic profile of a population exposed to an aerosol during outdoor working hours: women, children, the elderly, those who had been indoors or who lived further from Compound 19 were dramatically underrepresented among the dead, and the spatial distribution of the cases did not scatter as a food contamination would scatter. It mapped onto a narrow corridor, extending approximately 50 kilometers to the southeast of Compound 19, following precisely the wind direction recorded for the night of April 2nd, 1979. The animal deaths among livestock in villages to the southeast mapped onto the same line, extending the corridor further into the surrounding countryside. Bad meat does not go in straight lines 50 kilometers long, Matthew Messelson of Harvard University would later observe. But wind can do that. In 1979 and through the 1980s, however, the outside world could not prove what it suspected. The Soviet Union denied everything, and without access to the city, to the medical records, to the victims and their families, to the facility itself, Western governments remained in the position of having a compelling and well-supported inference that they could not transform into proof. The number of the dead was never publicly established with precision during the Soviet period. Later investigations confirmed a minimum of 66 fatalities. Some estimates, accounting for the gaps and falsifications in the documentary record, suggest the true figure was higher. between 100 and 105. The exact count remained permanently obscured. At Compound 19, the drying equipment was shut down. The facility was cleaned. Production of the Anthrax 836 strain continued at other sites within the biopreparat network. The program did not stop. It accelerated. Through the 1980s, the Soviet biological weapons effort grew to employ approximately 60,000 people at dozens of facilities across the Soviet Union, developing weapons based on anthrax, plague, smallpox, and a range of other pathogens. In some cases, engineering antibiotic resistance specifically to defeat Western medical countermeasures. The truth about Sverdlovsk began to emerge only after the Soviet Union collapsed. In 1992, Boris Yeltsin acknowledged, in terms that were carefully indirect but unmistakable in their implication, that the 1979 outbreak had been caused by an accident at a Soviet military facility. The contaminated meat story was false. The following year, a team led by Matthew Messelson was permitted to travel to Yekaterinburg. The city had been renamed after the Soviet fall, to conduct the most thorough independent epidemiological investigation the city had yet allowed. Messelson and his team spent weeks interviewing survivors and the families of victims, examining the geographic distribution of cases, reviewing such records as had survived the systematic falsification of the preceding decade, and cross-referencing their findings against satellite imagery and meteorological data from the relevant period. Their analysis, published in the journal Science in 1994, was unambiguous. The Sverdlovsk outbreak had been caused by the accidental release of anthrax spores from a single point source, Military Compound 19. The contaminated meat story was, as the spatial distribution of casualties alone had always suggested, a lie. It was the deadliest outbreak of inhalation anthrax in recorded human history. The scale of what had happened: more than 60 people dead in a single Soviet city in a single accidental release from a facility whose existence the Soviet government officially denied, took years to fully absorb, even for those who had always suspected the truth. That same year, a microbiologist named Ken Alibek, the deputy director of Biopreparat, who defected to the United States and began to describe from the inside what the Soviet program had actually been. His account, published eventually in a book titled Biohazard, described a biological weapons enterprise of a scale that dwarfed anything Western intelligence had imagined. Dozens of facilities, tens of thousands of workers, warheads ready for deployment, strains engineered for antibiotic resistance. And at the center of it all, produced by the ton in closed Soviet cities, was the same organism that Robert Koch had found in the blood of dead cattle in a Polish village in 1876. Unchanged, patient, waiting, a missing filter, an unread note, a Friday evening decision by a shift supervisor not to delay the resumption of production long enough to check whether the exhaust system was safe. The same organism that had killed animals in the Nile Delta 3,000 years earlier, that had killed workers in Bradford's wool mills in the 1870s, that had killed the sheep tethered on Gruinard Island in 1942, had now killed more than 60 people in a Soviet city in 1979. And it had done so not because of any escalation in its own biology. The Sverdlovsk strain was not a new organism. It was not a modified organism. It was not an engineered pathogen. It was the same ancient, patient armored spore that Koch had found in the blood of dead cattle in a Polish village in 1876. The spore had not changed. The spore never changes. And that realization, the understanding that the most lethal biological disaster in modern Soviet history had been caused not by science advancing beyond control, but by a missing filter and a note that was not read, follows you out of Sverdlovsk and refuses to be put down. It was the ordinary human failures that attend the management of any industrial process. Only this one manufactured something, with a mortality rate approaching 100%, because it raises, with quiet and unavoidable insistence, the question that opens the last chapter of this history. If an industrial facility employing thousands of people, with multiple oversight mechanisms and 3 operational shifts, could allow this to happen by accident, what might a single, determined individual do on purpose? 22 years after the wind blew southeast over Sverdlovsk, someone dropped 5 white envelopes into a postbox near Princeton, New Jersey. And the answer, when it came, was quieter and more ordinary and more terrible than almost anyone had imagined it would be. The attacks of September 11th, 2001 took 2,977 lives. They took them in under 2 hours, in fire and collapse and the terrible noise of a Tuesday morning that the world could not stop watching. They were visible. They were enormous. They produced a trauma that occupied every news broadcast, every political conversation, every waking hour of the weeks that followed, in a way that left almost no room for anything else to register. And so when the anthrax began to move, it moved quietly, the way it has always moved, without announcement, without spectacle, without any of the visible apparatus of an attack. It moved through the mail. The first letters were postmarked September 18th, 2001, 7 days after the towers fell. 5 envelopes dropped into a blue postal collection box on Nassau Street in Princeton, New Jersey, sometime between 5 in the afternoon on Monday the 17th and noon on Tuesday the 18th. The envelopes were addressed to news organizations in New York and Florida, the offices of ABC, NBC, and CBS News, the New York Post, and the tabloid publisher American Media Incorporated in Boca Raton. Each letter contained a powder. Each letter contained a typewritten note with phrases like "Death to America" and a postscript, "You cannot stop us. We have this anthrax." The powder was real. For more than 2 weeks, no one outside the organizations that received the letters knew they existed. The letters arrived. They were opened in mailrooms by people who had no reason to suspect them. Some of the anthrax they contained was a coarser, less refined preparation, dark brown granules that one scientist who examined it said resembled dog food, that caused the milder cutaneous form of the disease when it contacted skin. Postal employees and mailroom workers at several of the media organizations developed skin lesions. A 7-month-old infant, the child of an ABC News producer who had visited the network's Manhattan offices, developed cutaneous anthrax on his arm. They were treated with antibiotics, and they recovered, and the connection to any kind of deliberate attack was not immediately apparent, because anthrax arriving in a letter seemed, at that particular moment in September 2001, like a scenario from a thriller novel rather than from the world outside the window. And then Robert Stevens fell ill. Stevens was 63 years old. He was a photo editor who worked for a tabloid newspaper called The Sun, published by American Media Incorporated in Boca Raton, Florida. He was a British-born émigré who had built a quiet American life in the Florida sunshine, who loved the outdoors, who hiked, who had no connection to politics or terrorism or any of the forces that were then remaking the world around him. He was the sort of man who, on any other autumn, in any other year, would have been entirely invisible to history. On October 2nd, 2001, he arrived at a Florida hospital in the early hours of the morning, confused and vomiting, with a fever that the emergency room physicians initially assessed as consistent with meningitis. When an infectious disease specialist examined his cerebrospinal fluid under a microscope and found large rod-shaped bacteria present in samples that should have contained no bacteria at all, the diagnosis that followed was one that most physicians in the United States had never made in their careers and had never expected to make. Inhalation anthrax. The CDC was notified. The FBI was notified. On October 4th, the diagnosis was confirmed and announced publicly. It was the first case of inhalation anthrax in the United States in 25 years. On October 5th, Robert Stevens died. He was the first victim. He would not be the last. His death was only the beginning. In the space of the following 7 weeks, 32,000 people were placed on emergency antibiotics. The United States Senate closed its doors. The FBI launched its largest investigative task force since the Oklahoma City bombing. And the country understood, with quiet and undeniable clarity, that the oldest pathogen in human history required nothing more than a standard mailing envelope to become an instrument of national terror. The second wave of letters arrived in mailboxes on October 9th. 2 envelopes this time, both postmarked Trenton, New Jersey, both bearing the same fictional return address. A 4th grade class at the Greendale School, Franklin Park, New Jersey. They were not addressed to news organizations. They were addressed to 2 of the most senior members of the United States Senate, Senator Tom Daschle of South Dakota, Senate Majority Leader, and Senator Patrick Leahy of Vermont, Chairman of the Judiciary Committee. The letter addressed to Daschle was opened on the morning of October 15th by a staffer in his office in the Hart Senate Office building on Capitol Hill. When the envelope was torn and the powder inside was disturbed, it released a cloud of nearly pure, highly refined anthrax spores. The Daschle letter contained approximately 1 gram of material. 1 gram, the weight of a small paperclip. Within that gram were an estimated 1 billion spores, prepared to a standard of refinement that prompted one scientist who examined the sample to write, in an internal communication, that it was an extremely pure preparation and an extremely high concentration. He added 4 words that stayed in the records of the investigation for years afterward. These are not garage spores. The Hart Senate Office building was evacuated. The Capitol Police declared a biohazard emergency. Within hours, more than 24 people who had been in the building that morning were identified as having been potentially exposed, and arrangements were made for them to begin taking ciprofloxacin, the antibiotic approved for post-exposure anthrax treatment. The building itself would not reopen for 3 months. The Leahy letter was not found that day. It had been misrouted through an incorrectly read postcode and was sitting, sealed, in an impounded bag of mail at a State Department annex in Sterling, Virginia. A postal worker at that facility contracted inhalation anthrax from it before it was located. The letter was not found until November 16th, more than a month after the Daschle letter had been opened. when investigators working through more than 200 drums of quarantined Capitol Hill mail finally retrieved it. By then, the anthrax had been moving through the postal system for weeks. Sorting machines process mail at high speed, compressing, sorting, and mechanically agitating envelopes as they pass through, aerosolizing the spores inside those letters with each pass. Microscopic quantities of anthrax were settling into the air of postal facilities, depositing onto other pieces of mail, onto the surfaces of machines, onto the clothes and hair and hands of the workers who staffed the sorters. At the Brentwood Road Postal Processing Facility in Washington, D.C., through which the Daschle and Leahy letters had passed on their route to Capitol Hill, 2 postal workers had been breathing contaminated air for days without knowing it. Their names were Thomas Morris and Joseph Gersine Jr. Morris was 55 years old. He called a medical hotline on the evening of October 21st, describing symptoms: shortness of breath, fever, aching muscles, that the hotline advised him were consistent with the flu. He was told to rest and take aspirin. By that evening, he was critically ill. He died in the early hours of October 22nd. Gersine was 47 years old, a father of 2 daughters. On October 21st, he was taken to a hospital emergency room, treated for what was initially assessed as influenza, and sent home. He returned the following day, his condition having dramatically worsened. He died on October 22nd. 2 men who had not opened any suspicious envelope, who had not been warned that their workplace was contaminated, who had not been offered the antibiotics that Capitol Hill staffers received within hours of the Daschle letter being found. The asymmetry in the response, the speed with which senators' offices were evacuated and treated, set against the days of delay before the postal workers who had actually handled the infected letters were informed or protected, became one of the bitterest reckonings of the entire episode. The people whose hands had touched the weapon were the last to be told it was there. The Brentwood facility was closed for decontamination. When it reopened, it was renamed the Gersine Morris Mail Processing and Distribution Center. 2 more victims followed. Kathy Nguyen was a 61-year-old hospital stockroom worker in New York City who had no direct connection to any of the targeted organizations. She died on October 31st, likely from cross-contamination through mail that had passed through the same sorting machines as the original letters, though the precise mechanism was never conclusively established. And then there was Ottilie Lundgren. She was 94 years old. She lived alone in a small town in Connecticut. She had no connection to government, to media, to any person or organization that had been targeted. She was simply an elderly woman who received her mail as she had received it for decades and opened it. She developed inhalation anthrax. She died on November 21st, 2001, the last of the 5, killed by spores that had migrated through the invisible mechanics of a postal system that moves tens of millions of pieces of mail each day. From an envelope she had never seen and never touched, to a letter that crossed her threshold on an ordinary morning in a Connecticut town that had nothing whatsoever to do with any of it. She was, in the full context of this history, the 3,000-year history of an organism that has always found its victims without warning, without visible mechanism, without the courtesy of explanation, perhaps the most perfectly emblematic of all of them. The investigation that followed was called Anthrax. It became one of the largest criminal investigations in American history. More than 10,000 witness interviews conducted across 6 continents, More than 6,000 pieces of evidence recovered. 5,750 grand jury subpoenas issued. 5,730 environmental samples collected from 60 separate locations. The investigation cost the FBI and the federal government hundreds of millions of dollars and occupied a dedicated task force of investigators and scientists for 9 years. For 6 of those years, it focused largely on a former Army scientist named Stephen Hatfill, who was publicly named a person of interest by the Attorney General. Investigators placed him under surveillance, searched his properties repeatedly, and at one point poured water into a pond near his home, looking for buried evidence. He was never charged. He eventually sued the Justice Department for defamation and received a settlement of $5.8 million. His name was cleared entirely. Then the investigation shifted. Forensic analysis of the attack spores, applying a technique called multi-locus variable number tandem repeat analysis, which examines specific repeated sequences in the bacterial genome to identify genetic lineage, identified a particular reference flask, designated RMR 1029, as the most probable source from which the attack anthrax had been grown. That flask was held at the United States Army Medical Research Institute of Infectious Diseases at Fort Detrick in Frederick, Maryland. It was registered to a researcher named Bruce Ivins. Ivins was 62 years old. He had worked at USAMRIID for 18 years, specializing in anthrax vaccine research. He had volunteered in the early weeks of the Anthrax investigation to help process samples, offering his expertise openly and apparently without reservation. His security guard records showed, however, an unusual concentration of late evening and weekend hours spent alone in the laboratory's biosafety suite, the containment area where work with dangerous pathogens was conducted. In August, September, and October of 2001, the precise window in which the attack material would have needed to be prepared. In a typical month, he logged a few hours in that suite. In those 3 months, the hours spiked dramatically without explanation. He had access. He had expertise. He had, in the view of investigators, motive, a belief documented in his own emails that a high-profile anthrax attack would accelerate congressional funding for the vaccines he had spent his career developing and which had been languishing without adequate support. In July 2008, Evans was informed that criminal charges were being prepared against him. He was hospitalized for psychiatric care. He was placed under surveillance. His security clearance was revoked. On July 29, 2008, he died at home of an acetaminophen overdose he had administered himself. 8 days later, federal prosecutors publicly named him as the sole perpetrator. A 92-page summary of evidence was released. The Anthrax investigation was formally closed in February 2010. The case has never entirely closed in the minds of those who followed it most closely. Ivans's colleagues maintained his innocence. Scientists who reviewed the forensic methodology questioned whether the multi-locus analysis was sufficient to reach the conclusions drawn from it, whether identifying RMR 1029 as the probable source definitively excluded all other possibilities, given that the flask had been shared with other laboratories. Senator Patrick Leahy, himself a target, himself a recipient of one of those envelopes, stated publicly that he did not believe Evans had acted alone. A 2011 review by the National Academy of Sciences concluded that while the science was consistent with the FBI's conclusions, it could not definitively establish that the attack spores had originated from RMR 1029. The man named as the perpetrator died before he could be charged. The questions that his death foreclosed were never answered. The file is formally closed. The questions remain. What is certain is only this: 5 people who had no quarrel with anyone, who were doing nothing more than their ordinary work or receiving their ordinary mail, died because an organism that has existed in the soil of this planet for millions of years was placed, with deliberate intent, inside a standard white envelope. Whether one person placed it there or several, and whether justice was ever actually served, the organism itself remains entirely indifferent to the question. 5 white envelopes, 5 people dead, 17 infected, 32,000 on emergency antibiotics, a 9-year investigation of historic scope that ended with a prime suspect already in the ground. The oldest pathogen in human history, riding through the mail, patient as it has always been patient, waiting as it has always been waiting, requiring nothing more of the 21st century than it required of ancient Egypt. No upgrade, no modification, no laboratory enhancement. Only the same armored spore, the same dormant biology, the same capacity for the same devastation it has carried since the first farmers of Mesopotamia looked at their dying cattle and reached for the gods to explain what the ground had done. It was always here. It will always be here. The only thing that changed across 3,000 years of human history was what we chose to do with it. There is a field somewhere in Scotland, on an island off the northwest coast, where sheep graze in the rain, and the wind comes off the Atlantic, and nothing visible distinguishes this ground from any other ground in that part of the world. The grass is the same shade of grey-green. The soil is the same dark, peaty substance that covers the hillsides of the Western Isles. The sky above it is the same enormous, unpredictable Scottish sky, heavy with weather, moving in from the ocean, and the sheep are the same Cheviot ewes that graze these hills across the length of the country. You would not know, looking at this field, what happened here. You would not know that in 1942 a bomb was detonated on this ground, and 80 sheep were tethered in groups around it, and that they began to die within 3 days, and that the scientists who watched them die drew conclusions so disturbing that they were classified for decades. You would not know that this small oval island was quarantined for 48 years, that warning signs ringed its beaches for half a century, that a government bought it for £500 and could not give it back because it had made it uninhabitable, and that the decontamination required to make it safe again took 4 years and 280 tons of formaldehyde diluted in seawater. You would not know any of this standing in that field, looking at those sheep. The ground does not show you what it remembers. That is the thing about anthrax, the thing that has defined its relationship with the human world for 3,000 years and more, that the ground does not show you what it holds. The soil of the Nile Delta does not announce that it carried anthrax in the time of Rameses II. It does not announce that the 5th and 6th plagues described in the book of Genesis may have been caused by the same organism that killed farmers in the West Riding of Yorkshire in the 1870s. The same organism that killed more than 60 people in a Soviet city in 1979. The same organism that was compressed into 5 white envelopes in New Jersey in September of 2001. The soil does not tell you this. It simply holds it. The spore does not announce itself. It does not announce its presence in a bale of imported alpaca wool, or in the exhaust of a military production facility, or in the powder settling at the bottom of an envelope. It waits. It has always waited. It will wait under the right conditions for a century, for longer. It has been recovered from permafrost that began to thaw and released what it had been holding since before living memory. It has been found in soil samples from fields that have not been grazed for generations, still fully viable, still capable of germinating in a warm and nutrient-rich environment the moment one presents itself. There is a particular quality to this kind of patience that does not have a good name in English. We speak of things lying dormant, lying latent, being preserved. But none of these words quite captures what the anthrax spore does, because they all imply a kind of passivity, a mere absence of activity, a waiting that is simply the failure to be active. The spore is not merely inactive. It is in some sense that resists easy description, actively inert. It has constructed its own conditions of survival. It has enclosed itself in a shell of almost incomprehensible toughness. It has suspended every metabolic process that would consume energy or expose it to decay. It has done, in biological terms, everything that can be done to ensure that when the conditions for revival return, it will still be there. This is not passivity. It is something closer to an act of will, though of course it is not will. It is evolution. It is the result of millions of years of selection pressure that rewarded the organisms most capable of surviving the longest through the worst conditions. But evolution at this length of scale produces results that are not easily distinguished from intention. The anthrax spore looks, to the human mind, as though it means to survive, as though it has decided to wait you out, as though it knows in whatever way a protein-enclosed piece of genetic material can be said to know anything, that you will eventually create the conditions for its return. This quality, the biological patience that looks like intention, the indestructibility that looks like defiance, is what has made anthrax so persistently present at the intersections of human history, where our reach has exceeded our understanding. It was present at the dawn of agriculture, when we first began domesticating the animals and working the soils that brought us into sustained contact with the places where it slept. It was present as those agricultural civilizations expanded and traded and carried contaminated hides and fleeces along the first trade routes, seeding new soils with the spores that would wait in foreign lands for generations before the next conditions of revival arrived. It was present as the Industrial Revolution mechanized the processing of those hides and fleeces and created, in the wool mills of Bradford and elsewhere, environments of sustained aerosol exposure that killed workers in ways that defied the medical understanding of the time. And it was present, patient, inert, sealed inside its protein shell, in the moment when Koch looked through his microscope in a small Polish town in 1876 and became the first human being to understand what he was actually looking at. That moment deserves a certain quality of stillness in the imagination. A young country doctor, alone in a converted corner of his examination room, with a microscope his wife had given him as a gift, peering at the black blood of dead cattle in the lamplight of a rural winter evening. He had no collaborators, no institutional support, no tradition to build on, because the tradition of microbiology was, at that moment, still in the process of being created. He was working from first principles, from the discipline of careful observation, from the conviction that what he was seeing was real and that it meant what he thought it meant. And what he found in those shining bead-like spores that appeared in the cultures under certain conditions was not merely the explanation for anthrax. It was the explanation for the field that holds what it holds. It was the explanation for why the farmers of ancient Egypt experienced what they experienced as divine punishment. The sudden, inexplicable death of their animals, the recurrence in the same fields after years of apparent safety, the impossibility of cleaning it away, or reasoning with it, or predicting its return. Koch gave the ground a name for its memory. He gave the spore a biology. He transformed the oldest agricultural mystery in human history into something that could be studied and eventually addressed. Louis Pasteur did what Koch could not or did not bring himself to do. He turned the knowledge into theater. The field at Pouilly-le-Fort in 1881, the 24 vaccinated sheep standing healthy beside the 24 unvaccinated dead, the journalists and agricultural officials and skeptics who arrived to see the results and left as converts. This was a performance designed to change minds, and it succeeded completely. It changed medicine. Between that demonstration and the present day, the history of infectious disease is essentially the history of following the logic that Koch and Pasteur established together, applied to organism after organism, disease after disease, in an expanding circle of understanding that he has saved more human lives than any other set of ideas in recorded history. But it did not change anthrax. Nothing changes anthrax. Not in the fundamental sense, not in the sense that matters most. The spore that was present in the soil of Egypt in 1491 BCE is, at the level of its essential biology, indistinguishable from the spore that was refined and dried and packed into those 5 envelopes in New Jersey in September of 2001. The organism did not evolve in any meaningful sense across those 3,000 years. It did not need to. It was already, from an evolutionary standpoint, essentially perfect. What changed was not anthrax. What changed was what we chose to do with our understanding of it. The German agents who infected Allied livestock in World War I understood what Koch had published. The scientists at Porton Down, who loaded anthrax spores into bombs and detonated them over the tethered sheep of Gruinard Island, understood what Pasteur had demonstrated. The Soviet engineers at Compound 19, who built the exhaust systems and the production lines, understood, with the precision of industrial engineers, exactly what they were producing and exactly how effective it would be if deployed against a civilian population. And the person who prepared the spores in the Dachel letter, who brought the aerosol preparation to a quality that prompted the observation that these were not garage spores, understood everything that Koch and Pasteur had revealed. They used that knowledge with deliberateness. They used an organism that required no modification and no enhancement, an organism that had been killing human beings since before the word anthrax existed, and they placed it in a standard envelope and dropped it in a postbox. Consider for a moment what it means to say that an organism has a history. Anthrax does not have a history in the way a nation or technology has a history. Something that develops and changes in response to the pressures of the world it moves through. Anthrax has a presence, a continuous, unbroken, essentially unchanged presence across a span of time that makes the whole of recorded human civilization look brief. The Bacillus anthracis that Koch found in cattle blood in 1876 was, at the genetic level, almost identical to the organism killing livestock in ancient Mesopotamia 3,000 years earlier. The Sverdlovsk strain, when its genome was finally sequenced, showed only 13 base pair differences from its closest common ancestor with Western vaccine strains. 13 differences in a genome of more than 5 million base pairs. The organism barely changed. It had no need to change. It was already, across millions of years of evolutionary history, as lethal and as durable and as patient as it needed to be. And this is the thing that no weapons program and no biosafety protocol and no international convention has yet found a way to address. It does not require a weapons program. The potential that every Cold War biological weapons facility was trying to harness was already present, fully formed in the natural world, in the soil of every continent, in the dormant biology of a spore that has been waiting with no particular urgency and no measurable impatience for exactly as long as it has needed to wait. We know this now, with a precision that the Woolsorters of Bradford could not have imagined. We know the organism's name, its structure, its life cycle, its mechanism of lethality, its extraordinary durability. We know how to grow it, and how to kill it, and how to detect it, and how to treat it. We have written the treaties that ban the use of it. We have built the laboratories and the biosafety protocols and the emergency response systems designed to contain it when it escapes. We have, in the 2 centuries since Koch first photographed the spore, accumulated a body of knowledge about Bacillus anthracis that would have seemed miraculous to any physician who watched the Woolsorters of Bradford die without being able to name what was killing them. And yet the spore itself is unchanged. The ground holds what it held. That is the nature of anthrax's relationship with the world we have built. We can know it completely and still not control it entirely. We can name it and study it and weaponize it and ban the weapon and decontaminate the island and close the investigation and still find ourselves, at the end of all of that, in the presence of something that was here before we arrived and will be here after we are gone. The field on Gruinard Island, where the sheep now graze in the rain, is as safe as 4 years of formaldehyde treatment, and 30 years of subsequent monitoring can make it. The scientists are reasonably confident. The sheep are alive and well, and have been for more than 3 decades. But reasonably confident is not the same as certain, and the spore that was there in 1942, whether it is gone now or whether it is waiting deeper than the formaldehyde reached in some sealed microenvironment beneath the island's surface, does not send word of its condition. It maintains its silence and its inertness in exactly the way it has always maintained them. And accuracy is, in the end, what the history of anthrax demands. Not panic, not the kind of generalized dread that anthrax stories so easily generate, but accuracy. The honest acknowledgement that what we are dealing with is not a new or emerging threat, not a problem created by the Cold War or by terrorism or by the failure of any particular safety protocol. It is a 3,000-year-old biological reality that we have chosen at various points in our history to ignore, to misunderstand, to worship as divine punishment, to study with brilliant precision, to weaponize with cold calculation, and to confront with the full resources of modern epidemiology and law enforcement and international treaty. And that we have not, in all of that time, made it go away. Somewhere in the soils of this world, in Scotland and Russia and Kazakhstan and the Nile Delta and the fields of Roman Italy, and the grazing lands of ancient Mesopotamia. The spores that caused the deaths described in the oldest agricultural records of human civilization are still present, sealed, dormant, not dead, waiting for the warmth and moisture and nutrition that will wake them. They have been waiting for a very long time. They are patient enough to wait a great deal longer. And that, in the end, is the thing that the full history of anthrax leaves you with. Not a call to action, not an urgent warning, not the breathless anxiety of a crisis that demands immediate response. Something quieter and more durable than any of those. The simple, steady, uncomfortable awareness that the world is older than our understanding of it, that it holds things we cannot see and have not named, and that among those things are organisms of extraordinary patience and extraordinary lethality, that have been here since before we began keeping records of what was here. We named it, we studied it, we vaccinated against it, we weaponized it. We signed treaties promising not to weaponize it. We broke those promises. We killed people with it and died from it, and investigated it and built entire institutions around the management of the threat it represents. We decontaminated the island, we closed the investigation, and still it waits, as it always has, as it always will. Good night,